Now, the impact of outdoor antennas, it's effectively the impact of outdoor antennas on data rate is dramatic. I got this from a source, but I can tell you that we've actually found it much larger variations. In other words, this would be an indoor case where you've got indoor antennas. The moment you move outdoors, you get a massive increase in the data rates. The reason why data rates increase so fast is nowadays people use modulation techniques, which can use a very simplistic scheme when its signals to noise is bad. It can then go up to, say, quadrature, 16, 64, QAM, and so forth. So it can use much more complex, where you can do much more bits per symbol. And that is the reason why you find this sort of very fast gradient. The gradient is most significant. You can see this is distance from tower, where the signal is, of course, weak, because there it would be at its lowest rate, and you could find increases, and we've certainly seen increases of 10 to 30 times in data rate. I must note, of course, gain is important, but the most important part is actually going from inside a house to outside a house. You get virtually 16 to 25 dB gain just taking an antenna outdoors. What's MiMo? And of course, this is a part we love because antennas are integral to getting MiMo advantages. MiMo was introduced with 4G LTE and with the latest Wi-Fi standards. If we just look at 2x2 MiMo, there's two ways you can get it. You could have a base station. Sorry, my laser point is just a bit slow, which transmits from two antennas, and you could then have the boat also having two antennas on. And by transmitting over the MiMo, we try to find two decorrelated paths. So we'll try to find a way of getting two data streams, because those antennas are somewhat decorrelated, being far apart. Typically, the further apart, the better. That's certainly going to be important when we're doing 4x4 MiMo, but I would say when you're doing 2x2 MiMo, by far the simpler technique, and it gives fantastic results, is to use cross-polarized antennas. In other words, to use two polarizations, because there you are certain that you're going to get that doubling of the data rate, and you're certain you're going to get it regardless of reflections and so forth, which you almost rely on in the case we're using two spaced antennas. But you can use spaced antennas, and it's often required if you're going to use two omnis, because omnis, it's very difficult on an omni to get both horizontally and a vertically polarized omni antenna.